There we go. All right. So, very good, very good, very good. Question?
Can you make this available on?
Oh, is it not yet? All right. Certainly I can do that. There we go. This is going to be fun. We're going to skip a bunch of boring slides and watch a fun video instead. So, welcome once again to database theory. Today we will be talking about one of the more mathematically complicated aspects of database management. We will be talking about joining tables. We will then talk about grouping data, which is almost so easy as to be trivial. And then, although I'm sure you won't find it trivial when I put it on the test, data processing in SQL Server. So, joining tables. You guys remember the cheese and crackers thing? That was joining tables, right? All right, moving on. No. So, frequently, it is useful to join the data from multiple tables together. Another way you could think of joining, cross-referencing. Let's say, for example, I have a table full of products. Each of those products has a product ID. Perhaps I have sales of said products and I have purchases of said products. Sales and purchases seems to be synonyms, so I'm not quite sure how to square that circle. Maybe this is number we've bought versus number we've sold. Let's go with that. But you'll notice that in order to, analyze the data, it's like, okay, how many anvils have we sold? You have to look through the table and say, okay, how many of product ID 105 do I have? 0. We have sold 0 anvils. By the way, if you haven't noticed, these are all things from Looney Tunes cartoons. Roadrunner, Acme Incorporated. However, if you look at instant water, we've sold 7 of those, but these are kept in different tables, and it's, not necessarily obvious that they should even be the same table, right? When we have a table describing all of the products that we sell, this should not be modified when we make a sale. We should have a sales table that updates and adds rows when we sell things, right? These should be different tables, but it is very useful to be able to see we have sold 7 super outfits, 4 dehydrated boulders, and 3 cans of invisible paint, right? This is what a join is for. So, this is your basic join syntax. If we imagine we have 2 tables, right? One is the first table, the table that we are joining the other one to. The other is the table that we are joining, table 1, table 2. Select has become a little bit broader in this case. We can now select columns from both tables. All of the tables that we are joining, we can select columns from them. If those columns have the same name, we have to further say what table they're coming from. We use dot syntax to do that. But if the table name is unique to that table, you can just say it. So, here's an example. Let's say we have a table, purchase orders, and a table, purchase order lines. We join purchase order lines where purchase orders dot purchase order ID is equal to purchase order lines.purchase order ID. So going back to these tables, that line expresses when the product IDs match, that's a cross-reference, right? When product ID is the same in both cases, that's where the rows line up. And that's where we consider that to be really one record. Does that make sense? Okay, cool. So, very good. There are several types of joins that we will be discussing over the course of this lesson. The first and default variety is the inner join. We will then discuss three varieties of outer join, left, right, and full. We will then discuss cross joins, but really only as a you should probably never be in this state type thing. Occasionally you may have use for it, but not. So, consider the following inner join on these tables that we've been discussing. Select product ID sold and purchased from sales S, inner join purchases P. So notice that we are aliasing the tables. One thing that you may have noticed here is that's a bloody long thing to write. Right? That's just annoying. If we alias the sales table as S and purchases as P, we can use more compact syntax. Make sense? This is not this is optional. You don't have to do this. You can use the full name if you wish to. Just understand you'll probably see things that look like that. Make sense? So far so good. Any questions? Okie dokie. So, the term inner here is optional. You don't have to say inner join. You can just say join. Join maps to inner join. If a column is not unique, it must be qualified. So, in the case of product ID, the product ID occurs in both the sales and purchases table. Therefore, we have to say which table we are reading, right? So, using dot syntax, S dot product ID, sales product ID. If you've done an inner join correctly, because this is like the ID, it should be the same in both cases anyway. But nevertheless, there are two occurrences of it. And you can imagine, I hope, a situation where two tables have a common category name that's not the ID, right? Make sense? So far, so good? Okay. This is the most common type of join. The output of this query, when run on this database, is the following. We have the sold and purchased columns, but notice which IDs have been taken. Right? We have only accepted as output records where the product ID matches in both cases, right? 100, 100, 5, 15. 100, 5, 15. 103, 103, 8, 10. 103, 8, 10. 101 does not exist in the purchases table. 102 does not exist in the sales table. Neither of them appear in the output. This is what it means to be an inner join, right? If it's not common to both, it isn't shown. Does this make sense? So far, so good? So, let's now consider a left join. As you can see, this is the same query. The only difference, we are asking for a left outer join rather than an inner join. Notice that the term outer is optional. If it's a left join, it is presumed a left outer join. There is no such thing as a left inner join. There is only one type of inner join. So far, so good? Have I bored you to tears? Not yet? Okay, I'll keep working
You
at
said
it.
there's no such thing as a left outer joint?
There's no such thing as a left inner join.
Oh.
There's only one type of inner join, and that's just an inner join. But with outer joins, you've got left, right, and fold. You're very welcome. So, this is the result of a left outer join. Notice all of the product IDs in the sold table are represented. Reminding ourselves, we've got 100, we've got 0, 1, 3, 4, and 6. Zero, 1, 3, 4, and 6. The point of the left join, if there is no matching value in the other table, a null is provided. So, what the left join means, everything in the left column is there. Not all of the things in the right column are there, necessarily, right? Not all of the elements of the purchased table are represented in this table. In particular, element 102 is the only value not appearing in the sales table. This one is not represented in the left joined table. Does this make sense? So if you wanted to sort of term this in natural language, you might say something like, the purpose of a left table, in this case, show me for everything I've sold how many purchases I have, right? In cases where I don't have any purchases, that information is still there instead of being omitted. Does that make sense? Any questions? Right outer joins are a similar symmetrical process. You may have guessed what the outcome is going to be already. Rather than having optional nulls appearing in the purchased table, we have optional nulls appearing in the sold table. Not table B, but table A can now contain nulls. Every record in the right table is represented, and for things that have no corresponding entry in the left table, you get none. Does that make sense? So it's the same thing, but you take the position of the A table and the B table and reverse them, and that's what you have. Does that make sense? Very good. Question?
Why would you not just switch the two tables?
I don't know. It does seem kind of, yeah, like, you should be able to just like get away with left all the time and never do a right, right? Yeah,
So, it's saying outer is optional, like I'm reading through, they're all optional, so then what exactly does the outer?
oh, it's just saying the outer keyword is optional. So when you say left outer, right outer, or what's it, full outer,
Yeah,
left, right, and full cannot be anything other than an outer join, so the word outer is redundant, so it can be removed. That's all it's saying. Does that make sense?
so was there any point where it was necessary? Since they included like it in the language.
So, to understand why that was put in there in the first place, you have to kind of dig a little bit into the history of SQL, right? SQL was not the original name for SQL. It was originally called SQL, which is why you hear some people call it SQL instead of calling it squirrel, because it's obviously squirrel, right? There you go. So SQL originally stood for Structured English Query Language, right? So the reason that you have these redundant words, which programmers very rightly reject as being redundant syntax, the reason you have it is so that it sounds correct as a sentence, right? You have to understand that we are in the 70s, right? We are in the same era as COBOL, right? I've shown you guys COBOL, right? Yeah. So that's the type of language that this was originally styled as. The reason it has so many redundant keywords is because it's supposed to read like English, right? So that's the reason. As a programmer, you can safely ignore silly human languages and work exclusively in the pure sanitary digital domain. You know, as a logician, I'm a trained logician, you know. As a logician, you eventually come to the realization that most logic is fuzzy and it's horrifying. So, there is one point in this table which is a perhaps interesting point. I've been too nice to you guys. I have to talk to this side now. Right here. If yes, sir. Hi.
Nice to see you.
Yes. You know, I try to. It's a hard room. This is a hard room. Even though like the last one is too long,
This one's too hot.
this one's like there's no optimal like size, you know? Like actually, if you want to know the truth, I believe what the intention was for this room was to have two narrow classrooms because it's got two doors and two light switches, right? And probably originally there was a wall that came right down here, but this was too small a classroom because you can only fit like.
You can kind of see where there used to be a wall.
Yeah, actually, right there, yeah, you can see it in the floor. Although, it's interesting, does that run like all the way? Yeah, if it's right, the door is like right in the corner like that one is.
Found a missing wall.
But, yes, but here's the issue, right? Like, given that, this is a room that only holds 16 students. Or no, wait, 20 students, yeah. Anyway. Why null here? Let me return to the query. S dot product ID. So why is this null?
Because it doesn't have a product ID, it's not
That's right.
share product ID.
Right. There's no product ID entry matching this ID, so it can't be found in the table, so it's null. How do we fix that? We modify the query to use the product ID from P instead. Now we have a more complete table. Make sense? This course is dire. So, full outer join. Outer is again optional. As you may expect, all values from all tables are represented. Where the products match, or where the IDs match, you get your, you get one record from that. Otherwise, one or the other of them is null, and these values are null correspondingly. So the full outer join contains, here's a question, at most, how many entries? If the number of entries in table A is n, and the number of entries in table B is m, how many entries do you have in this table at maximum?
Whichever is greater.
N
Nope.
plus n?
N plus m, that's right. Because at maximum, none of these entries correspond to each other. So you would have the full amount from both tables represented. Make sense? Yes. You would be correct of a left or a right join, right? Although, in that case, it wouldn't be the max of either of them. It would be just the number from one or the number from the other. Yes?
Do you know why they chose to have the syntax be inner versus outer? Because I feel like inclusive versus exclusive would be like more logically correct, I guess.
I have a slide that will demonstrate where the terminology comes from.
Alright.
Let me talk about cross-join first, though. So, cross-join is a bit strange. Each row from left to left table is joined with each row from the right table. There's basically it's like table multiplication. So when it says cross join, it means literally like the multiplication symbol.
Oh.
A cross B, right? So, yeah, it's like if,
Why is this the standard query language? Shouldn't we have a better query language than this?
it does the job well enough. It's like you know the QWERTY keyboard.
Yeah.
You know the principle of the QWERTY keyboard.
Oh, yeah, that's.
There is no principle.
It was
Well-
split off of typewriters, which spaced them out based on which characters are you least likely to press. They didn't want you to wear on one side of the typewriter. They spaced all the characters around as far away from each other as possible. So you might think you press lots of vowels, very often, because those are used all the time.
Mm-hmm.
They're spaced out very far apart from each other for a reason, because they don't want you to wear down that part of the typewriter where all the vowels are clustered.
Yes, I didn't know that. That's interesting. But basically, the question is why are we still using QWERTY keyboards when Dvorak keyboards are more efficient, right?
We're in 2D, that's why.
That's the reason, yeah. Basically, QWERTY keyboards work well enough, and the energy it takes to learn Dvorak is basically too much in comparison to the increased efficiency from using a Dvorak keyboard.
Wasn't QWERTY made for typewriters because people when it was just an ABC keyboard, people were just like typing too fast because they knew where all the keys were. So they mixed up the keys so it'd be QWERTY, so they wouldn't type as fast and they wouldn't jam up the keys. I've heard that somewhere, I think, I don't remember.
It's also, well, perhaps, like, that is actually a problem that you would have on old typewriters, because you'd have like a print head that would come down and strike a ribbon that would print the thing on the paper, right? And if you typed with letters that were too close to each other, there was a much greater risk of two hammers striking each other if you were typing too quickly. So that might also have factored into the design. But basically, like, the evolution is this. We had mechanical typewriters. People developed an electric typewriter for typists using the QWERTY keyboard layout because that's the one they knew, right? And you would sell more units if it was the keyboard layout you already knew, right? Electric typewriters eventually got wired into computers, bringing the QWERTY keyboard with them, and now we have, now we are stuck here basically for eternity. Because even the bloody phones use a QWERTY layout, right? So that's why SQL.
Right, we're into that, so.
Like-
Question, yeah.
Yeah, if you want to talk about like deeply invested code, like deeply invested code bases, like deeply invested legacy code bases, one of you guys mind closing the door, please? Thank you. You can't get much more deeply invested than SQL, because like, although COBOL is like largely deeply invested, it was only used for a period of time and then better languages have come along. SQL has been used continuously for over 50 years.
Deeply invested, I prefer the term sunk cost fallacy.
Sunk cost fallacy, yes. Like, non-SQL databases are attempting to do something about this, but they will probably never even achieve majority market share. Just because, like, there's too much that's already been done with SQL.
Especially because like even though there may be alternatives to SQL that work better, like SQL itself is still a perfectly functional thing. It's not like there's any real problem with it. So
Yeah,
there's
not
no
to mention-
precedent urge to change everything.
Yeah, not to mention if you like look at some of the details under the hood, like SQL databases are very highly optimized algorithmically. Like they've had 50 years of algorithmic optimization put into them, right? It's like, it's difficult to conceive not using SQL databases because they're like, there's almost no so settled a product as an SQL database. So yes, we're in a situation where we have to learn stupid stuff in a stupid language because it's the thing everybody uses.
But you're gonna come across that a lot in this field.
Not just this field.
In many fields.
Would it be
Doesn't have to
massively
be
disruptive to change the syntax?
See, you could do an approach like what they do with YAML as opposed to JSON and write a new compiler that will compile old SQL code as well as the new standard. But this is like, fundamentally it's still gonna be the same language. It's still gonna have cross joins, right? One way or another. Speaking of which, cross join, right? So if I have a stupid marker that doesn't work. I whip it across the room except I hit somebody because the garbage is there instead of there. Sometimes I dramatically whip markers across the room. That's a thing you'll find out about me. Has to be the right room though. Don't want to hit anybody. Because in the end, I'm just a cowardly computer programmer. So this is what a cross join looks like. You guys get the idea? They kind of look like truth tables, to be honest. Right? For each entry in this table, you repeat this entire table and create a new row that way. That's how a cross join works. Basically, one way of conceptualizing a join is that you generate this every time, and then you cross out all the entries where the on clause doesn't match, right? Where's my pointer? Have you frozen?
Maybe that's, I think when we're moving the keyboard, you just gotta from the computer.
Oh. I don't think that's not it.
Oh gosh, I'm just picturing now like how massive some like cross join tables could get if you had like a lot of columns of data. Like that's an exponential equation.
Well,
That's
it's
not fun.
It's not exponential, it's multiplicative. If you have n, if you have n rows in this and m rows in that, you end up with n times m entries.
No, but I mean like the amount of entries in a cross join. Like looking at that, it looks like you're picking multiple. Like the 15 repeats again and again,
Yes,
all the way down to 25. So the more columns that you have in like both or like either table, the larger the amount of rows in a cross join would be.
the number of columns do not enter into it.
Okay.
So let me show you, let me extend this a little bit, just a little tiny smidge, all right? Let's say I have I, Roman numerals, IV, V, VI, right? Oh, no, I'll put that one on the back so that it still has some semblance of making sense. VI, V, IV, right? So what you end up with is the following. I, dot. You see the pattern? Right?
Yeah.
You're not crossing a table with its own rows, or with its own columns. The table entries stay the same with respect to each other, within one table, but, did I get that? I think I got that backwards, but that's the same as it is here, it's like 4, 5, 6 instead of, it's 6, 4, 5 instead of,
So then, there's no primary key then, because it, like from these, there's like repeats.
yeah,
Aren't there?
it's not clustering on primary IDs.
So then is this
Primary
still
keys.
like technically a table? Or,
Yeah, I mean, it's a table because it contains rows. Is it useful? No, it's not useful.
I mean, my next question was gonna be, when would you use a
Never.
cross join?
Never, you'd use it never.
Life.
I have to teach this class.
so what was the original purpose for it then?
So basically, originally, right, and this is actually the slide we're on, this was the old syntax prior to the year of our Lord 1992. Prior to 92, this was the syntax for doing a join. This was before join was introduced as syntax. So you would do a cross join, and then you'd use a where clause to filter for the particular, IDs matching in both cases. So this is what's produced in the back end, and then you filter that to get your results. So that's what but why would you need this without filtering? You wouldn't, ever, for no reason at all. If you see it, it's a mistake. If you see it, it's an error, right? But in the older, prior to 92 syntax for this, it makes it a little more obvious, like, what's going on, you know? Is this making sense?
I think so.
No.
No, I mean. Alright. You can join three tables. You can join three tables by including multiple join statements. Any questions? You can do different types of joins on different types of tables. If you want to do left join, left join. Left join, left join. You can get nulls all the way down if you want. Alright? Yes. For example, here's one on the community hospital database. We are selecting first name, last name, medication description, and dosage. All of these things are contained in different tables. Patients, from patients P, we join unit dose orders U. So, for the same patient ID. So the unit dose orders table keeps track of how much of a dose each person is on for each person, because that's ordered by a doctor, presumably. Then we join the medications table. The medications identify, the medication ID from unit dose orders, which is contained only in the medication table and not in the dose table. Doesn't make sense at all to have the name of the bloody medication in the table that tells you how much of it to give to someone, right? The medication, well, actually this is description. Okay, all right, they probably have the name in there. Description, medication description. All right. Take 2 tablets and call me in the morning, right? Where the medication ID matches up to the medication ID in both of these tables, there you go, and then you can order by last name, first name, medication description. Yeah, that's right, folks, you can throw more clauses on these, order bys, wheres, and the one that we're going to see later, which is group by. This is a sample table. Additional data, this is a different example. Alright. We've got employees, alright. Employee IDs, first name, last name, department, title, supervisor, and salary. And I hope that's not in dollars. Canadian dollars at least. Kind of feels like that though, doesn't it?
No, it's in cents.
It's in, it's in company dollars.
What is the, what currency do they use in Firefox?
Ooh, credits? Lots of science fiction uses credits.
Probably credits.
Yeah. Energy credits? Sounds good.
Maybe it's in thousands of dollars.
I mean, so our clerk is making $400,000. I mean, I'd like to work there.
I think it's actually in
Canadian
Pokemon
Tire
dollars.
money.
Pokemon dollars. Ah, yeah, there you go. Wow. So like you
Realistically though, it's
for
probably
like
just
a,
on a
and this is salary, so this is yearly.
Yeah.
So like working as a clerk for 1 year, you earn just about enough. You have 100 Poké dollars left over for food, and then wow, this kind of reconstruction. Yeah, everybody's rich.
It's credits in core planet.
Yeah, there we go. Yeah, Republic credits are no good out here. I need something more real. So, anyway, the president doesn't have a supervisor because they're the president. So, data. Why am I showing you this data? Guess what? You can join a table to itself. That's right. So, Why might you do this, you ask? Sometimes a table cross-references data from within the same table. Notice the supervisor category. The supervisor category contains employee IDs. So, Simon Tam's supervisor is 102, who is Zoe Washburn, VP of Sales, right? So, you know, these entries refer to other entries within the same table, so it makes sense to join the table with itself so that you can look up things like the first name, last name, department title, and supervisor name, right? So basically, if you want a view that said something like, here's the person's name, here's their supervisor, you need to join the table to itself. This is fine and easy. All you do is you just, from table, E1, join same table, E2. Give them different names though. Otherwise, most likely a syntax error. Questions? Okie dokie. So, the only difference though, or the only problem here, if we ran this, we would have a missing somebody. As you notice, the president does not have a supervisor. So, according to an inner join, the president would be left out of the table. If you want it to say president, supervisor, nobody, I supervise myself, you change it to a left join rather than just a inner join or a default join. Does this make sense? Any questions?
So then that sample table that we showed, this is before doing the joins, right?
That's right.
Okay, so, but we don't have an example of like what it looks like.
I mean, I could run it for you if you want, like in my brain meets.
So that, okay, so for the first one, it would look like that, just not the first line, basically?
This is how it would work. I'm going to simplify things, alright? So I'm just going to do first name of employee with first name of supervisor, right? So first entry, Malcolm, comma, look up supervisor, that's null, nothing to join it with. Supervisor is null. So name supervisor. Next, we have Zoe. Zoe, supervisor is 101. This is cross-referenced to this entry. First name from that entry is Malcolm, so you end up with Zoe, comma, Malcolm. Next entry, Jane, spelled like Wayne, but Jane. Supervisor is 102, so 102 is cross-referenced to this one. Get the first name. Zoe, you see how this is working?
Okay.
Yeah? Any questions? Good. Can we move along? Yes, hopefully. So. I'm going to skip this one. All right. Slightly more interesting diagram. So, guys take math, right? Discrete math? You guys do set theory at all? Yeah? Well, sets. This is another reason, this is the slide explaining why left, why right. So, sets. This guy in the middle, this is an inner join. It gives you all the elements of A and B which overlap, right? Left join gives you all of A plus all of the B's that overlap with it, right? Right join, all of the B's plus all of the A's that overlap with it. Full outer join, everything in A, everything in B, and also the things that overlap between A and B. And you can, if you exclude things where the key is null, you can get either the elements of the left elements that do not intersect with A, or the right elements that do not intersect, right? You can get all of these options. And if you're crazy, you can also do all of the elements with no intersection, right? Now, in practice, these are the ones that you'll be using most commonly. The inner join, the outer join, and the left join. As one of your esteemed colleagues noted, the left join and the right join cases are simply inverse of the other of each other. If you take the A table, assign it as the B table, swap the positions of the tables, you've turned a left join into a right join. So you don't really need operators for both, but we have operators for both because this is SQL. So, there you go. This one, and that one. Those are the important ones. Question?
Would you include the rest of them on the exam?
Probably not. Notice I said probably not, though. Well, you know, there's always a possibility. There's always a possibility that one of you will open up one of your exams and find a golden ticket, right, to my wonderful factory where I make test questions.
It's doing that well for a minute, you do it.
I know.
Do we get to inherit? Do we get to inherit it, but
You get to inherit all of my tests and my test writing scripts.
oh good.
Yeah. Okay. Enough said about join. Let's talk about grouping. All right. Or do we need a moment? All right. All right. Grouping. Consider the following queries. Select count from admissions, right? This gives you the total number of admissions. Select nursing unit ID from admissions. So far, we know how to count the number of rows, but we don't know how to count, for example, what are the number of sales of, like, how many sales entries do we have of a particular item in a table, right? This is what group by is for. The group by clause allows you, in combination with functions which give out a result, right, for you to group items with like values together and then perform an operation on them individually. Does this make sense? So, for example, let's say I had the following data. A1, A3, B7, A4, B2, C9, B10. right? Select, let's give these names, N and M, I guess. Select N, sum from table. There. Group by N. Right? So what it does is it says, okay, I got an A. Got an A there, got an A there. Okay, I'm gonna take the sum of all those A's. So your output is A is 1 to 4, the 8. A is 8. All right. B, we got one there, and there. That's 7. That's 9. There we go. That's 19. Quick maths. B is 19, and we got the C. C right there. We got C at 9. That's your output. Make sense? Hopefully this makes sense, right? Good. Any questions about that? No? Should be fairly straightforward. He said about the whole class. Except for the silly SQL-y bits. So, group by must be used in conjunction with an aggregating function. Things like count, sum, max, these are aggregating functions because they take many inputs and produce but one output. Multiple groupings are allowed, and of course you can also add an order by there in order to order the results. So, this is the generally accepted sequence of clauses that you have in select queries. Select from where group by having order by. Select list of columns from list of tables where list of conditions, group by list of expressions, having condition ordering by expressions. We're going to discuss having next week. Questions? Okie dokie. Dates processing. Okay, I'm going to show you a video now. Hopefully this will be more entertaining. This video is from my absolute favorite YouTube channel of all time, Computer File. Sometimes I show this one just for fun. This is about time zones.
Sooner or later.
Oh, that's quite loud. Calm down, sir.
Every programmer has to deal with time zones, and I can't really offer much advice here. I can offer a cautionary tale. I can tell you why you really should never, ever deal with time zones if you could help it. Let's imagine that someone has built an application that lets you calculate how many seconds something is in the past. You type in a date and a time, it gives you the number of seconds. And they look at that and think, okay, that kind of works for me, but let's add a little box that lets you change the time zone. So if you're comparing between now in New York and 5 days ago in London, you can work that
Or
out.
is it?
And that's fine. The little drop down lets you change which hour forward or backward of Greenwich you are. Brilliant. Sooner or later, after it gets a bit bigger, they'll get a call from Australia. And Australia will say, not trying to accents. I just shouldn't do accents. Australia will say, hello. By the way, we're 9.5 hours ahead of Greenwich. And the program will go, really? I say, yeah, 9.5 hours. So, oh, okay, I'll add a special case for you, that's fine. Then a little bit later, someone will call from Nepal, and they'll say, hello, we're 5.25 hours ahead of Greenwich. And they'll say, really? I say, yeah, we've been that for ages. Yeah, 5.25 hours. Great, okay. And they'll put in a special case, and maybe they'll look up the list of time zones, the canonical list that tells you what everything is. They'll make sure they've covered every time zone in the world. And then autumn will come along, and we'll get a call from England. And England will say, excuse me, we're an hour out at the minute, what's going on? And they'll work, hold on, the clock's just changed. That's fine, no, we dealt with that. We made a note of when daylight saving changes for us, and we put that in. And England will say, no, see, daylight saving changes a week earlier for us. It's different depending on where you live. We shift our clocks back a week before you do. And at that point, generally the programme will start to hold their head in their hands and realise what they've got themselves into. And that's fine, they'll put that in and they will deal with each country shifting to daylight savings time on a different day. And they'll look at the file that tells them how to do that and they'll copy all that in. And then they'll get a call from someone in the southern hemisphere again who'll say, yeah, well, we're not shifting back in the autumn, we shift forward. Our spring is in November. And then at that point they'll generally start looking longingly at their intoxicant of choice and wondering whether they should have a quick drink before keeping going. And then they'll code that in as well. And then they'll get a call from Samoa, out in the Pacific on the international date line. And Samoa will say, hello, yeah, we skipped today the other year. And the programme will say, what? Yeah, we skipped today. We went from December the 29th, 2011, to December the 31st. We shifted from one side of the international date line from being hours and hours behind Greenwich to being hours and hours ahead of Greenwich. It helps us with trading with Australia. Can you take account of that when you work out how many days things are and how many seconds things are in the past? That's fine. There's a file that tells you when any country has changed its time zone. It turns out that happens fairly often. But they're announced ahead of schedule, so as long as you keep that file updated and code that into your program's logic as well, it'll be fine. Then you look back and you notice that during World War II, England had double British summer time. It went completely onto BST and then just added an extra hour, so it was 2 hours ahead of Greenwich despite having Greenwich. It's fine, you deal with that. It's changed. You never started talking as if it was you or me, because I've done this before and it's really, really frustrating. You make sure that you subscribe to the list of when countries are going to change their time zones, which happens, apparently, many times. Like, sometimes, several times in a year, because governments change over. And then the programme, this mythical programme, gets a call from Libya, who in 2013, with only a couple of days' notice, decided that they weren't going to put the clocks back. With enough notice that it wasn't possible for anyone to get the update out in time, and meaning that every Libyan computer, no matter what operating system it ran, was an hour out. It's okay, you read the news article about that, and you hurriedly code that in as well. And then you get a call from the West Bank, where the Israeli population is on a different time zone to the Palestinian population, because one is following Israel and one isn't. And now you have two populations of people in the same location who are following different time zones. And now they're all having to ask themselves whether they're on this time zone or this one, depending on who they are and where they are. And there's no way to code that into your program. And then you get a call from the historian who says, right, I'm trying to calculate some times back in the 18th century. And we changed from the Julian calendar to the Gregorian calendar. And it's not that we lost about 3 weeks, it's just that we skipped right from this date to this date and missed the others. And can you code it so that it just kind of works that out for me? And it's fine, because someone else has already told you when those dates are, and you can code that into your program's logic as well. But now it's looking really long and really complicated, this tangled mess of spaghetti code that somehow works out. And then you get a call from the Russian historian who says, yeah, we only changed the Gregorian calendar in the 20th century. And it turns out that the dates that you skip change depending on your location. And can you deal with that as well? And then you get a call from the British historian who says that until, I think it was the 16th century, the year started on the 25th of March. Just to blow your mind, on the 24th of March, 924, and then it will be the 25th of March, 925, and that is the next day, because you have gone from December 31st, 924, to January the 1st, 924, because it goes in that order, and it's massively complicated. And then you get the call from the astrophysicist, who says, by the way, we just had a leap second. And at this point, you just kind of go, what? Leap seconds. Because the Earth does not rotate at a constant speed. It slows down, it speeds up as tectonic plates move about and magnetic fields shift or something like that. And so occasionally, the International Astronomical Union will work out whether we need a leap second. And if you do, the clocks go 23, 59, 58, and then it's 23, 59, 59, and then instead of going like any sensible time zone would, it goes 23, 59, 60, and everything breaks because suddenly you have 61 seconds in a minute. So depending on your implementation, either your clock gets 1 second out of sync with the rest of the world, or it repeats a second. The way you're meant to deal with this is something called the Unix timestamp. A number file, I think, has talked about this before, that you have this number that started at the first exact second of 1970 and increments 1 second per second, constantly, tick, tick, tick. And that's great because what you're meant to do is you take whatever date has been given you and you calculate that as a Unix timestamp and you put that into your database. And that'll just deal with leap seconds, except it doesn't. Of course it doesn't. Because you have universal coordinated time, which includes leap seconds, and then it repeats occasionally, and it just includes 23, 59, 60. And then you have astronomical time, which does not include leap seconds, and has steadily been getting out of sync with the rest of the world because we need to look at the stars and design telescopes around it. And what you learn after dealing with time zones is that what you do is you put away your code. You don't try and write anything to deal with this. You look at the people who have been there before you. You look at the first people, the people who have dealt with this before, the people who have built the spaghetti code, and you go to them and you thank them very much for making it open source. And you give them credit. You take what they have made, you put it in your program, and you never ever look at it again. Because that way lies madness.
Am I insane if I think that whole process sounds fun?
Yes. Yeah. That's okay though. You have to have a very specific type of brain damage to be a programmer. Oh, that's actually too much light now. So there's a little bit of fun for you. That wasn't me, by the way. I may sometimes seem like that, but that wasn't me. Actually, that's from like 11 years ago. I'm sure it wasn't me.
You sure it wasn't?
So, it's open source, but are the people working on it paid or are they volunteers?
See, that's always a difficult thing to say, because like, there are companies that employ people to work on, like IBM and people like that actually do employ people to work. Oh my goodness, I just realized I'll probably have to cut that whole segment from the video. Shoot, now I'm gonna have to do video editing. Gosh, darn it.
You should use DaVinci Resolve.
Well, you see, my videos will be perfect when they are like Lily Wanda's chocolate, completely untouched by human hands. So, yeah, you know, IBM employs people to do things like do security work for the Linux kernel, which is open source software, which they don't make any money on directly, but plenty of companies owe their existence to the fact of the Linux kernel existing and being secure, so it's worth their time and investment to employ people to do that. So I imagine this is along those lines. Just because you work for a private company doesn't mean that you're not working on open source software. It is also possible to make money on open source software too. Anyway.
Because if you're making money, then it's just not open source.
No, all that open source means is that you can download the source code.
Right, yeah.
Right? Yeah, so if you're, you know, open source, there's
Basically, you make money off of open source software when people are too lazy to download the source code.
Or people are too lazy to figure out how to compile it. So there's one piece of software called Ace Sprite, which is used for sprite editing, and like it is a bugger to try to figure out how to install that thing, particularly on Linux. But you know, yeah, I know there's a project that they figured it out.
No, I think, like, the actual repository, it has a build script now, so you can
Oh,
just-
Well,
yeah.
that was nice for them to add after I spent, you know,
Right?
at
Yeah.
least 10 minutes trying to figure out how to compile it.
Yeah.
Okay. I see I have some Ace Sprite enjoyers in the class. I'm gonna skip a bunch of these slides because I don't know why it's necessary to talk about how in 1582 the Catholic Church introduced the new calendar and named it for the current Pope, Gregory the.
This thing is 56 slides long, that's a lot of padding.
I know, right? Like, this is a little bit interesting. These are the date formats that are preferred in different parts of the world. You can see that, like, most places in the world will prefer either day, month, year, or year, month, day, or some combination of the two.
Once again, America.
Month, day, year is one that exclusively Americans like.
Once again, America is the problem child.
Yeah, I mean, really. And I guess the justification is like, when you speak it, you usually say like February 2nd, 1933, right? But,
Yeah, I mean, you know, been saying like the 2nd of February, 1933, whatever.
I mean, but you could say that, there's no reason you couldn't say it.
Yeah.
America. But look at Canada, right? Canada, all three, you can expect to see in this country. Because of course, you know, given our proximity to the States and the fact that there are so many Americans actually living in this country, you know, they bring their date preferences with them.
Canada is just a bastard child of several countries.
No, Canada is a colonial export economy. Is it the British Empire or the American Empire?
Yeah.
Yeah, minority is American and it's not.
French forever for Romans.
Yeah.
Literally everywhere else.
I mean, like, there's also the issue of imperial, you know? Like, imperial measurement is still used in the States.
Have you seen the Canadian flow chart from here, like where you use it?
No.
It's like,
I once
you
had
use
the
it-
idea.
if you're like,
Sorry.
doing this, you use imperial if you're measuring a human body or.
Or doing construction work on a house, that's also an imperial domain, yeah. I don't know, it's,
I once had the idea to create a measurement system that is based on universal constants.
yes. Well,
So,
I mean, this is kind of the idea, like a meter is formally defined as some fraction of the amount of distance that a photon travels in a particular interval of time. I think that a kilogram is still defined by an actual weight kept in a glass case in France somewhere. So basically, the way that what you should take from all of this, right, from this whole lecture, science is madness, all right? The attempting to measure the world is folly. Just live your life, and it doesn't really matter if it's a tablespoon or a slightly heaping tablespoon of baking powder in your pancakes, all right? Date format, though, in SQL should say what the class is actually about. As of SQL Server 2008, the default date format is year, month, day. Big to small. Big endian. Previous versions, blah, blah, blah. We don't really have to worry what the previous version said because this change was made 17 years ago? Quick maths. You can set the date format using set date format, but why would you need to? Because this change was made 17 years ago. Day, month, year, preferred in much of the world. Year, month, day, it is the opinion of the slides that this is the unambiguous best choice. Month, day, year, preferred in the United States. Year, day, month should be avoided. Month, year, day should be avoided. Day, year, month should be avoided. Dates functions are scalar. Scalar functions can be used wherever an expression is used. Everybody, I hope, knows what an expression is. We have some functions though, don't pack up. We've got some functions. Date diff. So if you have two things which are dates, dates are formatted like this. Year, month, day with hyphens. If you feed two of those into the date diff function, it will tell you what the time difference is between those two dates in terms of whatever date part you specify. Year, quarter, month, day of year, day, week, hour, minute, second, millisecond, microsecond, nanosecond. For example, difference in days between 2022 1/1, January 1st, 2022, or July 29th, 2024. 940 days, although it felt a lot longer than that. Date diff 2022, in months, 30 months. In years, it's 2 years, same dates. So here's one thing to note. It's rounding down.
Okay, that's what I was gonna ask.
Yeah. It's taking the floor of this. So for example, going from 2024 to, or 2004 to 2024, result is 19 years, but a person born November 15th, 2024 is not 20 on September 1st, 2023, right? Date diff extracts the year from both dates and performs subtraction without considering months or days. If you want more accurate results, you must bust yourself down to the next lowest level, or in this case 2 levels, and then divide by the number of days in a year. But of course, this way lies madness. Are there 365.25 days in a year?
On average.
Would that we were so lucky. Would that we were so lucky. Because this, of course, does not account for the fact that every 400 years we have to skip a weekday. Or have an extra one. I think it's skip a weekday. Madness. The madness is approaching. Date add is your way of taking a date, a formatted thing, and adding a certain number of another time unit to it. And guess what, folks? It also does subtraction, but you have to make the value negative. Make sense? Any questions? Good. Wait. Let me see here. Oh yeah. Get date allows you to insert the actual current date into your SQL table, or view it. This is particularly useful when you are creating things like sales records, right? Often, like this is one you will actually use fairly frequently in the wild, right? When you create a record, it's extremely useful to have recorded when that record was created. This is how you do that, right? Yes. To get the date without the time, the convert function can be used. So get date get date is actually a date time object, so you'll find like other languages like Python will have things like date objects, time objects, and date time objects, which include both a date and a time, right? So that's what this is doing here. Yeah. This one tells you what a person's age is based on their date of birth. So we have date difference between, in days, between their birth date as given in the table and the date at the moment, divided by 365. Take the floor of that, that gives you their age. You can also extract day, month, or year specifically from a date time object by using the day, month, or year functions. So you can alias them if you want as well. So, you know, if you just want to know what year people were born in, but you have a bunch of date time objects, just call the year function. Make sense? So far so good? See. Yes! We did it! Get out of here!